Welcome back. We're diving into large language models today, or LLMs, as I guess the cool kids call them. It's something I know a lot of you are curious about, and honestly, same here. Especially with everyone talking about this like agentic AI and RE.
Yeah, those are some buzzy terms you've run into. It's like, you want to know what's in the secret sauce, right? What really makes these AI systems tick?
Exactly. Like we hear about how LLMs can write and translate in code like almost like magic. But how?
Well, let's break it down. Think of it like this. You've got these superpowered language whizzes, right? These LLMs, but they need a specific kind of brain to do their thing.
So it's more than just like feeding them a ton of data.
Way more. That data is important, but they got to process it in the right way. And that's where something called the transformer architecture comes in.
Transformer architecture. Like those robots that turn into cars.
Haha, not quite. But it is about transformation, in a way. See, the transformer is a type of neural network. It's kind of how computers try to mimic how our brains learn.
Okay, neural networks, yeah. Those are like interconnected nodes that process information. Yeah.
You got it. And what makes the transformer architecture so special is how much it relies on attention.
Attention, like the LLM sits down and meditates or something.
Not exactly meditation, but it is about focus. Like, imagine you're reading an article. You don't give every single word the same amount of brain power.
Right, true. You kind of like zoom in on the keywords, the juicy parts.
Exactly. You're using attention without even realizing it. And LLMs, thanks to the transformer architecture, they do the same thing. They figure out which words are the VIPs in a sentence, how those words relate to each other, the whole shebang.
So they're kind of like highlighting the important phrases, making connections, and getting the big picture.
You're getting it. Before transformers came along, older language models, they'd try to understand a sentence by reading it like word by word, left to right.
Oh man, that sounds tedious.
It was, especially for long sentences. Those older models, called RNNs, they just couldn't handle all the complexities. But transformers with attention, game changer.
Okay, I'm intrigued. But how does this whole attention thing actually work? Is it like some super complex math equation or something?
There's definitely math involved, but the idea is pretty intuitive. Imagine each word gets to vote on how important the other words are.
Okay, so like each word's a little politician campaigning for attention.
Yeah. And the words with the most votes, they get more attention, influencing how the whole sentence is understood. It's like a popularity contest for words.
I kind of love that.
Yeah.
So by weighing the importance of different words, the LLM builds a deeper understanding. But how does this lead to like writing stories or translating languages?
That's where the training process comes in. This is where things get really interesting. LLMs are trained on a ridiculous amount of data. We're talking books, articles, code, the whole enchilada.
Like they're just constantly reading, absorbing all this info.
Exactly. And they learn by playing this giant game of predict the next word. You know, like the cat sat on the, and then you got to guess what comes next.
Oh yeah, that's how I learned to read probably.
Well, LLMs do this on a massive scale, billions of times, with all sorts of texts. And through that, they pick up the patterns of language, the grammar, the style, even facts about the world.
So it's not just memorizing words, it's understanding how language itself works. That's wild.
It is wild. It's like they're cracking the code of human communication. And this attention is all you need. Paper, that's what kicked off this whole revolution in how we think about language models. It's what led to all the cool stuff we see LLMs doing today.
So we've got transformers with their attention and massive training data sets, and that's basically the foundation for most LLMs.
Right, you got it. And that sets the stage for even cooler stuff like Agentic AI and RAG, which we'll get to in a bit.
Ooh, can't wait to hear about those. I'm ready for more mind-blowing insights.
Okay, so we've covered the basics. Now let's get into the fancy stuff. Agentic AI, it's like taking those super smart LLMs and giving them a boost, like a sense of purpose.
Purpose. Like they decide they want to write a screenplay
Mm.
about robots turning into cars.
Well, maybe. But it's more about giving them a goal, a mission, and letting them kind of figure out how to get there. It's about initiative.
So instead of just waiting for instructions, they're more like problem solvers,
Yeah.
right? Like almost independent.
Exactly. It's like, think about a self-driving car. You don't program every single decision for every situation, do you?
Right. It has to learn to react to things in real time. like if a squirrel runs out in the road.
Exactly. That's where the agency comes in. The AI has this high-level goal, like get the passenger to their destination safely, and it figures out the steps on its own.
Okay, so it's less about specific instructions and more about giving the AI a direction.
Perfect analogy. And the LLM, with all its language smarts, it's a crucial part of this whole process.
Right, so the LLM is still at the heart of it. But how does it actually contribute to this agency thing?
Think of the LLM as the brains behind the operation. It takes that big goal and breaks it down into smaller, actionable steps.
So if the goal is plan a trip to Paris, the LLM would figure out things like booking flights, hotels, maybe even suggest some cool museums.
Exactly. It can analyze preferences, research options, even create itineraries, all while keeping that big goal in mind.
That's pretty impressive. Like a super efficient travel agent that just gets it.
And this is just one example. Agentic AI is popping up everywhere, from managing calendars to controlling robots in factories.
Okay, so we've got agentic AI powered by LLMs acting all independent and making decisions. But what about that other term you mentioned, RG? How did that fit in?
RG, or Retrieval-Augmented Generation, that's all about supercharging the LLM's knowledge. It's like, imagine you have an LLM that's trained on tons of data, but it still doesn't know something very specific, like the latest news about a company.
So it's read all the encyclopedias,
Yeah.
but hasn't checked today's headlines.
Exactly. That's where RG steps in. It allows the LLM to connect to external sources of information like databases, the internet, even real-time feeds. It's about getting that up-to-the-minute knowledge.
So it's like giving the LLM access to a giant library, maybe even a research assistant.
I like that. With a RAG, the LLM can stay current, access specialized knowledge, even learn things that weren't part of its original training data. It's constantly evolving.
Okay, a reg sounds super powerful, I get that. But how does it actually work? Like,
Yeah.
technically, what's going on under the hood?
Think of a RAG system as a team effort. You've got the LLM, the brains of the operation, then you've got this massive knowledge base, all those documents, websites, databases, and then there's the retrieval system, the bridge between the two.
So the retrieval system is like the librarian that helps the LLM find the right book in the library.
Perfect analogy. The LLM might ask, what are the latest trends in renewable energy? And the retrieval system dives into that knowledge base, finding the most relevant and up-to-date info.
So the LLM doesn't have to know everything beforehand. You can just ask for what it needs when it needs it.
Exactly. And once the retrieval system delivers the goods, the LLM gets to work. It analyzes that information, uses its language skills to extract the key points, and then synthesizes everything into a response.
So it's not just like copying and pasting, it's actually understanding and processing the info.
You got it. And the beauty of RAG is that the LLM is constantly learning, growing its knowledge base. It makes it much more flexible and adaptable.
Okay, this is making a lot more sense now. So RAG gives LLMs this wider perspective, right? Access to a whole world of info. But I'm curious, are there downsides? Like, what if the information it gets is wrong or biased?
That's a really good question, and it's something researchers are thinking hard about. The reliability of RAG, it all depends on the quality of that knowledge base.
So it's kind of like making sure the LLM is getting its info from reputable sources, not just random stuff online.
Exactly. It's all about building trust into the system. And as RAG technology gets more sophisticated, we'll see more safeguards to address those concerns.
Okay, that makes sense. So we've got agentic AI giving LLMs a sense of purpose and RAG expanding their knowledge base. It seems like these two concepts, they really work together, right?
Absolutely. And when you combine them, it's like unlocking a whole new level of AI capabilities. Imagine a system that can not only plan complex tasks, but also access and process vast amounts of info to make informed decisions.
Wow, that sounds like we're on the verge of some seriously groundbreaking stuff. But before we get too carried away, I want to dive a little deeper into RAG. Like, how does this technology actually work in practice? Can we see some real-world examples? So RAG, it's like this super-powered search engine for LLMs, right?
Right.
Connecting them to a whole world of information.
Yeah, think Google on steroids. It's like having a research librarian inside the LLM, but way faster and more efficient.
Okay, I'm starting to get the big picture, but I'm still kind of fuzzy on the details. Like, how does it all work together? You mentioned this three-part harmony, the LLM, the knowledge base, and the retrieval system.
Right. So let's say you're asking our gay-powered LLM a question like, what are the most promising advancements in battery technology for electric cars?
Ooh, a question I've definitely Googled myself a few times.
I bet. So first, the LLM uses its language skills to kind of translate your question into a query that the retrieval system understands. It's got to speak the right language.
So the LLM is like the interpreter, making sure everyone's on the same page.
Yeah, exactly. Then the retrieval system, it goes to work. It's like diving into this massive ocean of information, scientific papers, industry reports, patent filings, anything and everything about battery tech.
Like sifting through millions of pages in a blink of an eye.
Exactly. It's looking for those golden nuggets, the most relevant and up-to-date info, maybe a recent research paper on a new solid-state battery, or an article about a breakthrough in fast charging.
Okay, so it's found the good stuff. What happens next?
Well, the retrieval system brings that information back to the LLM. And now it's the LLM's turn to shine. It uses its attention skills, its reasoning power to analyze everything, pull out the key insights, and even connect the dots between different pieces of information.
So it's not just dumping a bunch of data, it's actually making sense of it all.
That's it. The LLM might summarize the research findings, compare different battery technologies, maybe even talk about the implications for the future of electric cars. It's about providing a clear, comprehensive answer to your question.
This is making me think about all those times I've been lost in a sea of Google results trying to find a straight answer. With RAG, it's like getting that perfect, concise response, no more information overload.
That's exactly the goal. It's about making information accessible, cutting through the noise, and getting you what you need in a way that's easy to understand.
Yeah, you mentioned that ARG is being used in all sorts of fields, not just for answering tech questions. Like, what are some other examples?
Imagine students learning with AI tutors that can instantly pull up info from textbooks, historical documents, even simulations.
Wow, it's like having a personalized learning experience tailored to your exact needs.
Or think about doctors using RE-powered systems to diagnose diseases. They could access the latest research, patient case studies, analyze medical images, all to make the most informed decisions.
So much potential. But I do keep coming back to the concerns about bias and misinformation. How do we make sure these RE systems are getting their info from trustworthy sources?
That's a crucial question. It all comes down to the quality of that knowledge base. Researchers are working on ways to evaluate sources, look for signs of bias, and make sure the LLM isn't being fed misleading information.
So it's like building trust into the system from the ground up.
Absolutely. And as these technologies keep evolving, we'll see more and more safeguards to address those concerns.
This deep dive has been amazing. I feel like I've learned so much about LLMs in such a short time, from the basics of transformers and attention to these mind-blowing concepts like Agentic AI and RAG. It's incredible to see how fast this field is moving.
It is, and it's just the beginning. LLMs are already changing the world, and we're just scratching the surface of what they can do.
So much potential and so much responsibility too, right?
Mm.
It's up to us to make sure we use these powerful tools ethically and for good.
Couldn't agree more. It's an exciting time to be following all this, and I can't wait to see what the future holds.
Thanks for joining us on this deep dive into the world of LLMs. Listeners, I hope you found this as fascinating as I did. Until next time, keep exploring, keep learning, and keep those brains buzzing.